Hello, welcome to D58 Microprocessor and Microcontroller Lab experiment number 3 code conversion. The aim is to understand the concepts of converting numbers from one base to another base and to realize the operation of hexadecimal to decimal conversion in assembly level program for 8086. Here I explain about how to convert hexadecimal to decimal, and you have to do decimal to hexadecimal conversion by your own, and you have to write observation for this also in your lab. The logic is something like this. The input is for 16 bits. As example, the full scale value of 16 bit is FFH. You have to convert into 65535 in decimal. This 65535 nothing but 6 times of 10,000, 5 times of 1000, and another 5 times of 100, 3 times of 10s, and 1 times of 5. This is what in your memory organizations input you use two memory, low byte in one memory, low byte in one memory and higher byte in another memory. Whereas output will be something like this: 06 in one memory, 05 in another memory, 05 in another memory, 03 in another memory. At last, this also in another memory. So you use basically 5 memory. This is what the logic that you are going to do. How do you do this? So have FFH divide 10,000 with this given number. So 10,000 is decimal, so you need to go for hexadecimal equivalent of 10,000. So FF divide by hexadecimal equivalent of 10,000 will give quotient and remainder. The quotient is 6. Then store the quotient, which is a byte, into the memory, and have the remainder. From the remainder you need to find out number of 1000, and you have quotient, of course, remainder. Quotient could be this, store it in a memory, and you have the remainder. Again go for dividing that remainder with finding 100 to find this one. So there you do the things so on and so forth. At last you end with number of ones. This is what the logic behind this. Look at here. As example, you have FF and FF. The output could be 06, 05, 05, 35. Here the arrangement is something like big endian. If it is originally little endian, what happened? The 05 should be in 8000, 2000, but you are following big endian. It is better to go through with little endian. If you have any idea, you can change this memory allocations. This is the program. Of course, 8000, 1000 has your input data. These three instruction for loading your data into loading your pointer to the register DS and AX, and the DI for storing your destination, result into the destination index. First load AX with both 16-bit data and clear CX register and clear DX register also. Now have 2710, which is equivalent for 10,000 in BX, div BX. By dividing this BX, AX will have the quotient, DX will have the remainder. So in AX, what happened? Only the effective data will be in AL. It doesn't occupy complete AX register. It occupies only AL register. So AL register stored in the destination DI. Good. Now the remainder is in DX. Copy to AX again and clear DX and initialize BX with 1000. The 38 is equivalent for 1000. Then div BX. Then you are finding 1000 in the remainder of the earlier data. Of course, the quotient will be in AL and remainder is in AX. AL have effective data. AH will be 00 only. So you need to store only AL. So AL stored in DI plus 1, second memory of your result stored. And what happened? The remainder is in DX. Copy to AX, and what happened? 64 is 1100 equivalent, which is being stored in BX. Now clear DX and again divide BX, and the AL will have quotient, store it till getting these things. At last, this is equivalent for 10. Dividing with 10, you have the remainder. Quotient is your number of tens stored in DI plus 3, and remainder is number of ones, right, in last. Then straight away you don't need to you straight away you can store it into DI plus 4. That's it. This is what the program for converting hexadecimal into decimal. You need to do decimal to hexadecimal conversion in your regular lab. Look at this. You have to prepare algorithm, program and observation by yourself for decimal to hexadecimal conversion, and it should be included in your observation and record. Result you have to summarize very carefully what you have learned in this, what you understood, and what is the problem that you are facing when you do this program and all. You have to summarize this.